Let's see the next question in this exercise. From the top of a 7-meter high building, the angle of elevation has been given as 60 degrees and the angle of depression has been given as 45 degrees. We are supposed to calculate the height of the tower. So let's see the diagram for this one. Let this line represent the ground level, and on one side we have a tower. Actually, on one side we have a high building, and its height has been given as 7 meters. It's obviously perpendicular to the ground. This is the building, and its height is 7 meters. And on other side we have a tall cable tower, and it's again it is perpendicular to the ground, but its height is unknown. Let's assume that it is h. Now, the person is at the top of the building. Now, he makes two observations, once at the bottom of the cable tower and once at the top of the cable tower. So let these two lines represent their his eyesight. Now, the horizontal line of sight is this dotted line which I have shown, and we have been given two angles. One is the angle of elevation, which is towards the top of the cable tower, that is 60, and the other one is the angle of depression, which has been given as 45 degrees, and that's towards the bottom of the cable tower. Now, how will you calculate the cable tower, the height of cable tower h? So let's see. First, we are going to draw this diagram one more time because I need to break that distance h into two parts. Since this is a rectangle, I'm going to mark this part exactly same as this part, which is opposite side of a rectangle, which is 7 meters. And remember, the complete distance, the complete height of the cable tower was h, and out of that 7 was already taken, so the remaining distance from the eyesight level to the top of the cable tower is the remaining distance h minus 7. So now we have two triangles well defined. Let's see what kind of trigonometric ratio we are going to use. So first, let us assume that the distance between these two buildings is x. First, let us consider the triangle involving 45 degrees. Here, it doesn't matter whichever angle you want, you can take it first, but this is known distance, so that's why I'm taking this first. Now for this 45 degrees, this is the opposite side directly facing in front of it, and this is the adjacent side. So we are correlating opposite with adjacent. So the trigonometric ratio which we are going to use is tangent. We can write a generic expression tan of 45, which is opposite over adjacent. In this case, adjacent is 7. Opposite is 7, adjacent is x, and tan 45 we have a standard value which is equal to 1. So we are going to substitute that, and we will get the value of x by cross multiplication and substitution is 7. Now we can go to the second triangle, and again for this 60 degrees, this h minus 7 is the opposite side, x is the adjacent side, so we are again going to correlate opposite with adjacent. So we are going to again use tan, but this time for 60 degrees. So we can write a generic expression, tan of 60 degrees is opposite over adjacent. So we can write tan 60 from the standard trigonometric ratio tables, it is root 3. Opposite is h minus 7, and adjacent is 7. Why? Because we have already calculated the value of x. So if you cross multiply, 7 times root 3 will be h minus 7, and if you take h, if you keep h on one side and transfer that minus 7 on the opposite side, you get the value of h to be 7 root 3 plus 7, and you can take 7 common, and the final answer will be 7 in bracket root 3 times root 3 plus 1, and this will be in meters, and that's the height of the cable tower.